Imagine a world where robots don't just repeat, they adapt, watching us, learning new tasks in hours, then walking into factories, hospitals, and homes to help with the work we can't or don't want to do. That world isn't science fiction anymore. It's right now. From humanoids that can lift heavy parts to expressive androids that hold conversations, the latest wave of AI robots is breaking past the old limits of pre-programmed motions and into reasoning, dexterity, and safe collaboration with people. Today, we're counting down the most advanced AI robots in the world, the ones that matter, why they're different, and where they're actually being used. And stay with me, because midway through, I'll show you a new humanoid that moves in ways humans literally can't. And at the end, we'll talk about the single breakthrough that could turn today's prototypes into tomorrow's everywhere machines. One robot on this list just entered real auto production tests, and another has a brain powered by a new type of AI model built specifically for humanoids. We'll connect the dots. Section 1. Why AI robots are different now. For years, robot meant fixed, repetitive motions. The pivot to AI robots is about perception, seeing the world, reasoning, deciding what to do next, and learning efficiently, acquiring new skills from limited data. Two things unlocked this. 1. Better hardware, actuators, sensors, and hands with fine-grained control. 2. New AI stacks, vision language action models and foundation models that map words and images to real-world motions. This combo lets robots handle open-ended tasks, move through busy spaces, grasp odd-shaped objects, and recover from mistakes. It's also why humanoids are hot. The world is designed for people-sized bodies with hands, doors, ladders, and tools. The goal isn't to mimic us perfectly. It's to work in our spaces safely and productively. In a moment, we'll look at a humanoid that retired its hydraulic muscles for something quieter, stronger, and more agile. And it's heading from lab to factory. Section 2. Boston Dynamics Atlas Electric. Strength meets agility. Boston Dynamics shocked everyone by retiring its iconic hydraulic Atlas and unveiling a fully electric Atlas designed for real-world applications. The new platform isn't just quieter. It's intended to be stronger, with a broader range of motion, and it's being aimed squarely at industrial tasks, starting with Hyundai as a development partner. Unlike the acrobatic demos of the past, this version is about reliable manipulation, safer motions, and integration with enterprise software. Think robust hands, tailored grippers, and AI-driven control that can lift irregular objects and handle workflows alongside other mobile robots. Why it matters? BD has already commercialized Spot for inspection and Stretch for warehouses. That experience, over 1,500 deployments with Spot, feeds the path to scaled humanoids. Fleets managed through tools like Orbit and trained with a mix of model predictive control, reinforcement learning, and computer vision. This is the lab-to-factory bridge everyone's been waiting for. If Atlas is the athlete, who's the new hire already learning the assembly line? Section 3. Figure 02 plus BMW. Humanoids clock in. Figure moved fast. After announcing a commercial collaboration, the company ran weeks-long tests at BMW's Spartanburg plant, where the latest Figure 2 reportedly inserted sheet metal parts into fixtures for chassis assembly. Exactly the kind of dexterous, repetitive task that strains human workers. BMW called it an early test operation to explore safe production uses. It's one of the first public, credible trials of a general-purpose humanoid in real automotive production, not just a demo bench. Figure also popularized videos of its robot learning to make coffee after limited training and conversing via language models. A glimpse of how vision plus language plus action can compress learning cycles from months to hours. While marketing clips can overpromise, the direction is clear: task learning from human examples, not just hand-coded routines. Next up, a humanoid that's already walking the aisles at one of the world's biggest warehouse players.
Section 4. Agility Robotics. Digit, from pilot to production. Agility Robotics Digit is built for warehouses, bipedal with bird-like legs for stability, and arms designed for parcel manipulation. The robot has been piloted by Amazon and is now aimed at real deployments through Agility's RoboFab facility. The key pitch: human-scale mobility without needing to rebuild infrastructure, and task specialization, like tote handling, supported by perception and autonomy systems tuned for busy warehouse floors. Digit isn't trying to be everything. It's trying to be reliable at the high-value tasks that happen thousands of times per shift. Why it matters? If humanoids can move safely in crowded spaces, follow dynamic instructions, and offload ergonomic strain, their ROI case strengthens quickly. Logistics is a beachhead: consistent tasks, well-instrumented spaces, and huge labor needs. We've seen factory and warehouse talent. What about the brains that let robots generalize across tasks they've never seen? Section 5. NVIDIA's GR00TN1, a foundation model for robots. You've heard of foundation models for text and images. Now meet the push for foundation models for robots. In 2024, NVIDIA announced Project GR00T, and in 2025 it introduced Isaac GR00TN1, described as the first open foundation model for generalized humanoid reasoning and skills, a vision-language action model that takes multimodal input and outputs manipulation behaviors across different embodiments. The idea: train on a massive mix of robot trajectories, synthetic data, and internet-scale video, then adapt to specific robots and tasks with minimal extra data. If this works at scale, it could accelerate how fast robots learn, transfer, and recover in the real world. Why it matters? Instead of building a new brain for every robot, generalist models become a shared starting point, the way modern AI model hubs jumpstart apps. For humanoids, that means faster skill libraries, better zero-shot behavior, and sim-to-real pipelines that make factory-grade reliability less of a slog. With smarter brains, who's doing the most with hands? The hardest part of real-world work? Section 6. Sanctuary AI Phoenix, cognitive layers plus dexterous hands. Sanctuary AI is laser-focused on industrial-grade humanoids with dexterity, tactile feedback, and fine manipulation. The exact skills most factories need but most robots avoid. Their Phoenix platform pairs high-performance hands with a cognitive architecture that aims to learn and reason more like a person, not just execute trajectories. Sanctuary also emphasizes sim-to-real training and reinforcement learning for manipulation, announcing progress on training dexterous policies for their hydraulic hands, a promising direction for speed, strength, and precision in one package. Why it matters? Mobile manipulation is the bottleneck. Walking is solved enough. Hands that work all day are not. If Phoenix nails repeatable fine-grained tasks with safety and reliability, it unlocks huge factory and fulfillment demand where variability beats scripts. But humans trust faces. So what about robots designed for social interaction? Section 7. Amica and Social Robotics, Conversation as Capability. If hands are one frontier, faces are another. Social humanoids like Amica focus on expressive interaction, natural eye contact, micro-expressions, and voice-driven conversation. That matters because many jobs are human-facing: reception, training, guiding, and customer assistance. When paired with modern language models, these robots anchor trust and clarity while handing off physical tasks to more capable manipulators or mobile platforms. Caveat: conversational demos can be scripted or constrained, but the trajectory is obvious. Natural interfaces that work for everyone, not just engineers. As robots appear in public spaces, safety, privacy, and clear behavior policies determine what gets adopted. Speaking of public spaces, legged inspection robots are already everywhere, and they're a big part of why humanoids might succeed. We started with a simple idea: robots that learn. We saw Atlas pivot to an electric, factory-focused future, Figure 02 doing real production tests at BMW, Digit targeting the warehouse beachhead, Sanctuary's Phoenix chasing human-level dexterity, and a new class of robot foundation models like GR00TN1, promising to compress learning across embodiments. Here's my challenge to you. Don't judge the future by today's stumbles. Judge it by how fast these systems are improving. In a year, we may look back and say, that's when robots stopped being viral clips and started being co-workers. If you enjoyed this deep dive into the most advanced AI robots, hit like, subscribe, and tell me which robot you'd want working beside you and what job you'd give it first. In a future episode, I'll show how robot brains are trained in simulated worlds, and why a good digital twin can save a robot months of painful trial and error in the real world.